right, guys, so we are going to do some more Hess's Law. The last Hess's Law problem that we did, the 5.8, I believe it was. Yes, 5.8. There were only two equations that you had to manipulate. This one has three equations, so it's just a little bit more challenging, but not a big deal. Same rules apply. Remember, the rules are that you can reverse a reaction. If you reverse a reaction, you change the sign of delta H for that reaction. You can also multiply by a coefficient or by a number that changes the coefficients. But whatever you multiply by, you also have to multiply delta H by that same number. So let's figure out here how to solve this problem. All right, so again, they always give us the overall equation. This is what we're shooting for. And we need to rearrange these equations down here so that they look like this equation up here. All right. So the strategy I talked to you about in sample exercise 5.9 is for you to look at the overall balanced equation and then try to find the substances down in the multi-step. So here we have 2 carbon, and I'm going to go look for it down in the equations. I found it. There's carbon. Carbon's a reactant in both in this one and down here, so we don't need to reverse this reaction. However, the coefficient is 2, and the coefficient down here is only 1. So we need to multiply this equation by 2, which changes the coefficient of everything, but more importantly, we need to also multiply this delta H by 2. So we're going to end up doing that. So that takes care of carbon. Now let's look at hydrogen. Hydrogen is right here. It's a reactant, coefficient of 1. Down here, it is a reactant, coefficient of 1. Therefore, we don't need to do anything to this equation. Let's go on to C2H2. C2H2 is a product in our overall reaction, and it is a reactant down here. So we need to reverse this equation, which changes the sign of delta H from negative to positive. So whatever you do to the equation, you need to do to the delta H. Now, I'm confident that I did what's right here. And at this point, you're just going to add all these things together. So we have a little bit of really difficult math to do. No, just kidding. Not difficult, but I do need to figure out. So if I take 393, negative 393.5 times 2, that gives me a total of 787. So this is equivalent to 787, negative 787, I should say. And now I just add everything together. So I'm going to take the positive 1299.6 and I'm going to add that to negative 787 and add that to negative 285.8. Once I add all those together, my 1299.6, my negative 787, and my negative 285 together, you should get 226.8 kilojoules of energy. All right, now you might say, well, I'm not confident that I did the right thing, so I need to confirm it through that long process that I showed you in sample exercise 5.9. So let's go ahead and confirm this. All right, so I'm going to rewrite my reactants. Remember, these are reactants now. Whoopsie, what did I do? Always having technical difficulties here. All right, so remember, these are my reactants now, and these are my products up here. All right. So starting again, let's confirm this. So these are now my products. And these are my reactants. And yeah, that's about it. So let's go ahead and write these out. My reactants, other way. Oh my goodness. These are the products. These are the reactants now. Sorry, guys. Making some little technical errors here. So anyways, our reactants now are 2CO2. So that's this right here. And my H2O. And then these are my reactants as well. Remember, we multiplied them by 2, so it's 2 carbon plus 2 O2. And then we still have some more reactants. H2 right here, plus 1/2 O2. Now we get to our products. Our products are C2H2 plus 5/2 O2. So that takes care of those. Plus, don't forget, there's 2 CO2s here because of the coefficient we multiplied. Change the coefficient. And then our last product is H2O from right here. Okay, so figuring out what we have here, I see that we have 2 CO2 on the reactant side and 2 CO2 on the product side, so those cancel. I also have 1 water on the reactant side and 1 water on the product side, cancel. 2 carbons, that's going to stay because I don't have 2 carbons on the product side. And then I have a total of 2.5 oxygens over here. So that's 2.5 oxygens. And I have 2.5 oxygens over here. 5 divided by 2 is 2.5. I know you knew that anyways, but just want to make sure. So you combine like terms on both sides if necessary, like we did for the 2 oxygens. So those are going to cancel with this. Then continuing on, we still have this little hydrogen over here, and that is going to stay because we do not have one as a product. And then what's left of our products, the only product left is the C2H2. This is the same as this. Therefore, we did this correctly because we remember we manipulated the equations over here using our data and we got the right answer. Yay.